There is no such thing as DevOps engineer, but we'll get there, I guess. So DevOps, right? DevOps is not really about you doing the same thing what you were doing before and just changing your name, changing your title. It is not shared services that renamed to DevOps. It is not about being a system admin or sysadmin that is now called DevOps. And it is definitely not SREs, right? SREs is being an SRE is a technical role. We know exactly what SRE is. Being DevOps is a cultural movement. And the main idea behind DevOps is to break the silos. It is to remove the silos between different teams, and it is about not splitting any more teams into departments, right? It is about creating self-sufficient teams that are capable of delivering everything, absolutely everything related to an application from beginning to the end, from the requirements all the way until it is running in production. Most companies did not have that before for a simple reason, because most teams are based, what we called in the past agile teams, people who know how to write code of application, people who know how to test, maybe gather requirements. And those teams lacked operational knowledge. DevOps is about taking that operational expertise and putting it into those teams. Whether that's a single person who understands how operations works, or it is educating the teams, other members, does not really matter. It is about creating self-sufficient teams that are completely autonomous, do not depend on others, and are in charge of a single application or maybe a couple of applications from beginning to the end. And end is that it is running in production successfully. So that's DevOps. It is a cultural change. It is not a technical role, right? It is breaking the silos, creating self-sufficient teams. Now, when you look at DevOps, and if you look at the tooling that we are using today in those teams, it is very difficult to say what is DevOps, what is not DevOps. Actually, nothing is really DevOps, because most of the tools that we are using today existed long before DevOps word was even invented. But if you talk about being self-sufficient teams, then probably the easiest way to explain what we need to do today, no matter how you call it, is through a life cycle of an application. And life cycle of an application has different stages, right? They might not go in exactly the same order as the one that I'm showing you today, but more or less it's always the same. We define the architecture of an application, we create and manage infrastructure, we write some code, and by writing code, I mean writing everything. That's code of your application, tests, manifests, what's or not. We run some tests, we build something, we define how that something will be running somewhere in production, including production. We create releases, we run our applications, and we monitor and alert. That's more or less, on a very high level, the full life cycle of application. Those are all the things that those teams need to understand one way or another. Sometimes going very deep, sometimes on a high level. But you cannot, on a team level, those self-sufficient teams, you cannot say, I do not care about this, or I do not care about that. We can now discuss how deep you should go into any of those subjects, but all those things are responsibility of a team, a single team in charge of an application. So if we go now through all those phases, we can potentially identify what you should do and which tools you might want to use today. And if you start from the beginning, architecture today is all about microservices. Now, when I say about microservices, I have a slightly different definition than most other people have. I do not really care. When I say microservice, I do not care whether it's tiny or slightly bigger, whether it has 100 lines of code or 1,000 lines of code or 10,000 lines of code. What I really mean by microservice is that, among other things, it is small enough that it can be managed by a team, by one team. right? And a team is maximum, but absolutely maximum 10 people. If you have more than 10 people in a team, that's not a team. That's a school reunion. That's a soccer match, right? That's not a team. So team is a small number of people, 10 maximum. And we want microservices or smaller applications simply because if it's too big to be managed by those 10 people, then we need to extend the team and then we get into big mess. Those applications are decoupled, meaning that there is no direct relation between different applications and there is no direct relation between applications and the rest of the system. The only relation between everything are the APIs. We know the contract, we know the API, we talk with the rest of the system to API, and that's it. But development of an application is completely, and release and deployment to production and everything related to an application is completely decoupled from everything else in the system. And those applications contain only the business logic of an application. That wasn't the case in the past, but we learned better. We know not to do those things anymore. You do not put inside your application anything that is not business logic of that application, meaning that certificates are not there, service discovery is not there, routing is not there, storage is not there. All the things outside of the core business of the application is outside of applications themselves. They're managed completely separately from applications. And everything we do today is stateless. There are many reasons why it must be stateless. And when I say stateless, just to clarify, I do not mean that there is no state in the system. There is state in the system. Of course there is. We keep it in databases, on some network drives or whatever. But the applications that you are writing must be stateless, completely, 100% stateless. And they cannot have the data stored inside. They cannot have even, let's say, user sessions inside, cookies, nothing. And the reason is very simple. If we are talking about ever-increasing scale of what we are doing, our applications needs to be scalable and they need to be fault tolerant and they need to be highly available. And you cannot be highly available if you're not fault tolerant and if you're not scalable. And you cannot, it's extremely hard to scale stateful applications. Extremely hard. We do not do that. I mean, only specialized software like databases that spend endless hours, engineering hours, figuring out how to replicate state between replicas are doing it. Your applications are stateless so that they can be scalable, and they need to be scalable so that they're highly available. That's a prerequisite of everything absolutely we do, right? Now, I believe architecture, at least for now, aside, once we figure out that those are the basic rules, very, very basic rules of our application, we need to start thinking about where we are going to deploy our applications. And there is only one answer to that. Actually, there are two answers to that question. One that is used in vast majority of cases, that's simply Kubernetes. Kubernetes is like a black hole. Absolutely all innovation, absolutely all advancements that are happening today, actually not all, vast majority of innovation and advancements today are in Kubernetes. Not using Kubernetes is silly. Unless you have very old system that is legacy system and you just want to say, hey, let it rot wherever it is, or you have some alternatives, and those alternatives to Kubernetes are mostly based on public cloud type of vendors like AWS Lambdas or Google Cloud Run and so on and so forth. And even those alternatives to Kubernetes are actually Kubernetes themselves. Even if you don't see Kubernetes, there is Kubernetes or something very similar behind. So basically, Kubernetes is alpha and omega, and whomever is ignoring it today is making a huge mistake, unless we have a very good reason. There are some good reasons not to use Kubernetes, but they are very few in number and almost very rare, right? And that means, and Kubernetes is a huge beast. And that means that you as a team or you as a person, depending on how you split your responsibilities within that team, you need to spend considerable amount of time figuring out Kubernetes, because it's not easy. It's not easy for a good reason, because it's extremely powerful, right? You need to learn what are some basic resource types in Kubernetes, like deployment, replica set, pod, services, ingress, virtual services, storage, and so on and so forth. Huge amount of things. After that, you need to figure out some more advanced types, like, let's say you want your applications to be serverless, right? How are you going to do that? You're going to use most likely Knative. You need to figure out how Knative works. You need to, or as alternative, as I said before, you go for completely SaaS solution, like Lambda containers or Google Cloud Run that I mentioned before. You need to figure out storage, networking secrets, policies, service mesh, and in general, almost everything available today in CNCF or Cloud Native Computing Foundation. That is going to be the biggest task you have in front of you, right? Once you figure out Kubernetes and you're comfortable with it, and that will take some time, we need to start talking about infrastructure, right? How you manage infrastructure, what you do with infrastructure, and so on and so forth. And when talking about infrastructure, there are two components, at least two clear distinctions and components. One is the local infrastructure. It's something that people very often forget, right? How do we run our applications while developing before we make a pull request? And for that today, since we already agreed that you're most likely using Kubernetes, or you will be using Kubernetes, when we're talking about infrastructure, and when we are talking about local infrastructure, you're probably talking about K3D, which is K3S in Docker, or we are talking about Kubernetes in Docker. Those are the most likely candidate you will have today to run the part of the system that you care about while developing before you're ready to proceed with the lifecycle locally. If you're on-prem, first, my apologies, life is hard. Second, you're most likely stuck with Ansible. Ansible is slowly fading away, but you might be stuck with it, right? But I will ignore it for now. What really matters from infrastructure are the tools that I have on this side of the screen, right? That's Terraform, Pulumi, and Crossplane, right? And which one you're going to choose really depends on what are your use cases. You're going to go with Terraform if you want something that is tried, that is supported by everybody, that everybody likes, and so on and so forth. You're going to choose Pulumi if you prefer to write your infrastructure as code, like JavaScript or Go or Python, instead of using declarative syntax, which in my personal opinion is not a good idea. But hey, some people prefer it. And if you want to see the glimpse of the future of how the future infrastructure will work and how Kubernetes API will become a universal API for almost everything, or universal control plane for everything, then you're going for this guy over here. There it is, Crossplane, right? That is the future of, that's potentially the next step after Kubernetes, which is, if you think about Kubernetes as being control plane for your containers in a way, think of Crossplane as being control plane for everything. Not only what is happening inside of your Kubernetes, but also what is happening outside. Now, after that, once you figure out infrastructure, and when I say figure out, I always mean that you get to the point that it is fully automated. Everything I'm saying here today, except writing code, assumes that we all agreed that everything is fully automated. So no matter whether you're using Terraform, Ansible, Pulumi, Crossplane, whatever you're using it in a way that you write some code, you push it to Git, and that's where your job is finished. From there on, full automation. Some processes will pick it up from Git and run it and make whichever changes needs to be done, right? Your job consists of only two things. Everybody's job: write code, push to Git. Write code, push to Git. Nothing else. None of the other tasks are something, actually pull request review. So 3 tasks: write code, push to Git, review pull requests. That's all you ever do. If you do something else, you're doing it wrong. Then we go into building, right? You can completely forget about building libraries, storing them in Nexus or Artifactory and all that stuff. We don't do that anymore. The only thing that matters is container image. And I'm insisting on calling it container image. It is not Docker image, it is container image, because container image is a universal Docker image. Docker is just a tool that allows us to build images. And it is a very good tool that allows us to build images locally. It is a tool that you should never, ever, ever use inside of your clusters, because Docker shim is removed from Kubernetes. It forces you to adopt some bad practices. Once you get to building your container images outside your laptop, outside your computer, we are talking already of tools like Canonical, right? They all build the same image at the end. The major difference is how they work and how secure they are. Okay, so you figured out, you have your infrastructure, you know how to build your container images, and that's the only thing you're building. Nobody cares about anything anymore. It's container images only. We go into application manifest, right? You need to figure out how you're going to define what your application is, right? What is it? And today there are a couple of ways how we do that. To begin with, there is Helm and Customize, right? You need to choose whether you prefer templating or you prefer pure YAML. If you prefer pure YAML, you're going to use Customize. If you prefer templating, you're going to use Helm. My personal preference goes for Customize. Where is it? There somewhere. For Customize. But okay, that's a personal preference. I'm not going to sell you anything today. Once you figure out how you're going to define your let's say templating mechanism you're going to use to define everything, you need to figure out what will be the end state of your applications, how you're really going to define your applications and everything. And it's proven that if you define your applications directly as Kubernetes resources, that's extremely complicated. That's done in a way that almost nobody can understand except the selected few. So after that, once you figure out Helm, Customize, and all the jazz, you need to figure out how to define your applications as being applications and not a collection of Kubernetes resources, and how you can simplify the lives of everybody else in your organization. And for that, you're most likely going to choose Open Application Model or kubevela, or depending on which route you take, Crossplane. For a different reason than I mentioned Crossplane before. In this case, because of capability of Crossplane to create composites, which are the composition of different resources in a way that combines them all together and simplifies greatly how they work. And kubevela does something very similar, but it is limited on the application level. Okay, so you figured out, you have your infrastructure, you know how to build stuff, you know how to define your applications, which is what I'm talking about right now. You need to start thinking about local development. And local development is almost the same as CI/CD pipelines that I will talk about later. There is no excuse not to go through the same stages locally before you make a pull request and that becomes official, right? While you're typing, I'm a huge fan of test-driven development, behavior-driven development. While you're writing your code and you're writing your tests at the same time. You're running tests continuously, right? That's extremely important. While you're developing, you're continuously running tests in the background. You're getting notified when you make a mistake. You're scanning it for all types of security scanning and linting and what's not. And you're building applications and you're deploying them. And you're running another round of tests, because some tests need application at runtime. And all those steps, which is basically the vast majority of the steps that you will have in your pipelines, are executed locally all the time. And we do that typically today using a combination of tools. like that. If by local you mean literally locally on your laptop, you're most likely going to use something like Scaffold, for example. If you want to take a step forward and say, hey, I do not even want to develop my applications locally, then we are talking about tools like Gitpod or Octeto that allows you to convert your laptops into really dumb terminals. Basically, browser becomes the only tool that you need, and your whole development environment is somehow in some cluster completely transparent for you. Simply those tools, Octeto and Gitpod, will create all the resources you need to develop, to build, to test, to do everything you need to do during the development phase of your process. So you know how to develop locally, you know how to apply best practices, you know how to do that efficiently, and then we can talk about what happens once you're finished developing a feature. And when I say finished, I mean very short cycles, like maybe a day long or a couple of hours long. You make a pull request and then it becomes official. Then it goes through, wrong slide. Then it goes through pipelines. And pipelines are very similar to local development that I mentioned before. You're going to test, you're going to scan something, you're going to build, deploy, you're going to test again after you deploy something. The difference between pipelines and local development are the last two steps, and that is make a release, make it official, and deploy ultimately to production, right? Now, which pipelines you use almost does not matter anymore. There is very little innovation on the pipeline type of tooling. If you prefer Jenkins, that's okay. If you like Circle CI, that's okay as well. GitLab CI is okay. Any type of pipeline should do. Now, if I would have to make a choice, and the choice within self-managed pipelines, right? Not SaaS. SaaS would be a different category. You should choose Argo Workflows or Tekton. And unfortunately, I messed up my slides. I don't have the logos, but Argo Workflows or Tekton are most likely the future of your pipelines, whether that's CI, CD, whatever you want to call it, right? You're making feature branches. Nobody uses long-term branches anymore. You shouldn't be doing that. You develop in your own branch, personal branch. You're finished after half a day, maybe a couple of days. If you're very slow, you create a pull request. Your pipeline does everything it needs to do. You merge that pull request to the main line, and then it goes to production. And in the process of all that, we get to, and you already know how to do all those things. Some of them I discussed, but then we come to the critical part that changed drastically, and that is deployments, right? Traditionally, you're used to deploy stuff by executing imperative commands like you SSH into a machine and you deploy something, or maybe you're using Ansible to do that, or maybe you're using kubectl or Helm or Customize. Anyways, you're making some imperative commands from your pipelines that result in something being deployed. We are moving away from that logic. We are moving away from that concept and going towards GitOps. And what that really means is that your job, where deployment is concerned, is to make sure to update some manifests in a Git repository, right? Manifests that define what is production, what changed, what should change in production with this new release. And when you make those changes to Git, you have tools like Flux Flux or Argo CD that monitor Git repositories, and basically they are using pull model instead of pushing. So we are not pushing changes to production. We're having agents in production, constantly monitoring Git repositories and making sure that the desired state, and that's the state that is defining Git, is the same as the actual state. And the only two tools that matter in that area today are is Flux and Argo Workflows, right? You need to choose one of those two. They're probably the easiest tools of all the tools that I mentioned today. So, okay, so you got to the point that you know how to deploy your stuff inside your Kubernetes cluster, no matter whether Kubernetes is visible or invisible, like Google Cloud Run. And then we go into the next phase and the last phase, and that's our second to last phase, and that is how to monitor your stuff, right? And for monitoring, you have a bunch of tools, right? And you can choose any of those tools. Many of them are SaaS. I like SaaS or software as a service type of solutions. But one tool that you cannot avoid, one tool that is unavoidable and is a must, absolutely everybody has to have it, that's Prometheus. There it is. And Prometheus is extremely important because it is a standard. Almost every tool that you will adopt from now on has Prometheus as the metrics backend storage by default. It might not be the only one, but that's always the default one, right? Very often the only one. Like when you figure out how to scale your applications, whatever you're using, horizontal pod autoscaler or maybe Knative or something like that, Prometheus is where the data is expected to be. And same thing goes if you choose to do, let's say, canary deployments. Again, you're going to adopt tools like Flagger or Argo rollouts, and where are they going to search for information how to perform canary deployments? Prometheus. Prometheus is unavoidable, no matter whether you have additional monitoring tooling on top of it. Then you need to figure out how to deal with logs, and the logs, golden standard today, fluentd. You need to figure out where you're going to keep logs. We do not keep logs in the same place where we keep data metrics, simply because those are very, very different, and the tools are very, very different, and the formats of that data is, again, very, very different, and it would be very inefficient to keep metrics, which is time series, and the logs, which is free text, in the same place. So if you'll ask for recommendation for logs and you want to host it yourself, please try Grafana Loki. That's my preference today when you want to self-manage. If you're using some cloud provider, then use just whatever that cloud provider gives you. And finally, you might want to visualize things. I'm very much against doing what I'm about to say, but I understand that for majority of people, that's important. If you want to visualize, if you want to see what's going on, use Grafana. There it is. That's a golden standard now, unless, again, you have, as part of your cloud provider, some alternative solution and it comes for free or very cheap, then you might want to choose something else. And that's about it, right? And the last thing, actually, the most important thing once you reach production is not how you visualize your metrics, is not where you keep your logs. What is the most important thing once you reach production is alerting. And now when I say alerting, people usually think, hey, I'm going to receive a Slack message or a system is going to send me an email. That's not what I think at all. That's the push method of alerting, and that's aimed at notifying you that there's something wrong. And that's important, but not the most important thing. The most important thing about alerting is not for that it is not for you. It is not for humans. Alerting is for machines. We are going towards a world where machines are capable of self-healing. So when I say alerting, I mean there is a process that is monitoring metrics and figures out when there is something wrong and tries to do something like, hey, it's too slow, scale up. Hey, some processes are idle, scale down. I do not have enough capacity in my cluster, again, scale up. I have too much capacity, scale down. This process is down, restart it, and so on and so forth. So alerting is primarily for machines, and it's for humans only when when machines are incapable of fixing the problem. And even when that happens, even when you receive alert because machines could not know what to do with it, with the problem, your job first is to fix it, but second is to instruct machines how to do the same operation next time, right? So it's always increasing the knowledge, codified knowledge that instructs machines how to do something. And that was my very brief overview. I could speak about this for hours, but I understand that there might be some questions. So I'm going to stop here if you have questions. Otherwise, if you don't, I can continue.
Thank you, Victor. I guess we have some questions, but we also like you to continue because they are very beneficial tips and tricks from my point of view. So let's start one of those questions. Are there any good when using Kubernetes with monolithic apps? You know, everyone starts DevOps journey by setting up a Kubernetes cluster.
Yeah, there are very clear benefits. I mean, it also depends on how is your monolithic app. At the end of the day, whether it's monolithic or microservices is not that big of a difference. To me, the difference between monoliths and microservices is more on a human level. Do I need 50 people to manage this application or 5? Now, it really depends what somebody thinks when they say monoliths, right? You out of the box, you get benefits from Kubernetes. For example, if your application goes down, it will be recreated. If a node goes down, it will be moved somewhere else. If the whole data center goes down, it will be moved to a different. So you have fault tolerance out of the box. You have scalability, but that already does not depend whether it's monolith or microservices. Depends how your application is architectured. If your application can run multiple replicas, yeah, Kubernetes will scale it automatically depending on the workload. It fosters immutable everything, which helps with many things and so on and so forth. So there might be slightly less benefits with monoliths than microservices, but there are quite a lot. And on top of that, whatever new thing you want to use, whatever is the thing that you say, hey, I would like this tool, that tool is done for Kubernetes today. So you cannot not use it unless you want to ignore everything that everybody is working on from now on.
Thank you. Thank you. That question was from the audience, and I will ask one of mine. So you mentioned mutable and immutable infrastructure. I guess you advanced the immutable tier. So how hard it is to implement an immutable infrastructure?
It's not hard. It's almost the same as if it's mutable. It's more like something needs to switch in our brains to start thinking in those terms. Because let's say that you're doing on-prem, right? Complicated scenario. What you would normally do is create a virtual machine, and then you would configure that virtual machine to have everything you have. Like, I don't know, you need to run these applications there, you need to have this and that, right? Now, immutable is the same process, just the other way around. Instead of you configuring virtual machine, you configure virtual machine image. And then when it comes to create a virtual machine, you just create it from that image. So you just doing the inverse order of stuff. You create an image that has everything you need, and then you create virtual machines, exact copies without changing anything, while mutable is kind of, hey, let me run the server first and then install something. And the problem with the mutable is that over time, there is no way that those servers will be exactly the same. And you want them to be exactly the same because if you don't know what's inside, then you cannot control it.
Yeah, that's great. Actually, I think the problem among people is that you, as you said, don't know what is inside really. There are some environments, test environments, UAT environments, production environments, and they configure it manually. There are many configuration drifts between them. So when they want to provision a new environment, actually there is no easy way to do it. They do configure it from the very beginning. So I think you assume there is a maturity in your answer, that you assume that they exactly know what is inside, really.
Yeah. But if you don't know what's inside, then many of the things are pointless, because if I don't know what is inside of machine, then running tests, let's say I have staging environment, right? And I'm running tests that will give me confidence that this should work in production. But if I don't know what is inside of that cluster, how do I know that my production is the same? And if my production is not the same as staging, then I'm not testing what I need to test.
It's the ultimate question, I guess. Ultimate question no one wants to answer.
You need to go step by step, kind of. And once you start moving towards containers, then you will be forced to understand what your application needs, no matter what you do.
Yeah, thank you. So another question. What's the matter with Kubernetes support on Docker container runtime? Which points the organization should watch out for in order to survive through this process?
So
I think, sure.
I'm not. Anonymous attendee, ask additional questions if I didn't understand your questions, because I might be going in the wrong direction. But the thing is that Docker or container runtime, let's say, is just a component that Kubernetes uses to manage your containers, right? And there is something called container runtime interface, which is that the whole world agreed that this is the interface that Kubernetes or anybody else will use to communicate with container runtime. And absolutely every container runtime implemented that interface except one. And that one is Docker itself. So Kubernetes community for a long time had something called Docker shim, which is basically, Kubernetes talks through that through container runtime interface with Docker shim, and Docker shim translates that to Docker specific instructions, right? And then after years, community said enough is enough. We're going to remove Docker shim. If anybody wants to continue being in Kubernetes, it needs to implement the interface that we agreed. Docker will not do that, and it will probably never do that for a simple reason, because Docker as a company decided that it makes no sense for them to make business in clusters. That's why they sold Docker Swarm to Mirantis and other tools, right? Docker is focused on what is happening in your laptops. Docker as a company does not care anymore about your clusters. So think of Docker as a very useful utility on your laptop that has no place anywhere else.
Thank you very much. So again, one of my questions. What about your experiences in DevOps regarding legacy systems? Let's say AS400 or something like that. What would be the best move for such a company having that burden?
I cannot give a kind of answer that fits all legacies, because that's really impossible, right? Now, there is a fundamental problem with legacies. And first, let me first clarify that something being 20 years old does not, or being created 20 years ago does not mean that it's legacy. Legacy is something that has not been updated for a long time, that is not following the practices that we use today. So you could have a system that you wrote 20 years ago, and it is not legacy because you've been keeping it up to date, right? You've been refactoring it. Now, when people say legacy, they usually mean, hey, this is something that was done 20 years ago, and nobody cares about it anymore. Nobody is keeping it up to date. We just develop new features. And that means that you gave up, right? So if you gave up on something, why would you? My first question is, do you really want to invest in something that you don't care about? And if you do care about, many people say, no, but I do care about if you do care about, then why aren't you investing effort in refactoring, right? Refactoring is a part of every day's work. So the question is really whether it's worth the effort or not. If it's worth the effort, then you need to start investing like 50% of your time. I'm inventing the figure now into saying, hey, I'm going to start refactoring my application, legacy application, to be closer to today's principles, whatever those principles are.
Thank you. So another one. Do you have suggestions about how to make deployment pipeline more on demand? Which steps should be on demand and which ones should be done automatically?
I'm guessing now that by on demand, that person means you started by clicking a button.
Yeah.
If that is the question, then nothing should be on demand. Everything should be automated. No, let me clarify. Automatically triggered by something. So you should have a pipeline that is triggered when you create a pull request. You should have a pipeline that is triggered when a pull request is merged to the main line, right? So those are on demand in a way, but not on demand by you going to Jenkins and clicking button. They're triggered automatically by some actions you do in Git, right? So no on demand outside of being triggered by actions in Git.
Thank you. So what's the biggest challenge you witnessed so far when moving to a DevOps culture or DevOps technology stack from a consultant perspective?
Power struggle.
Political struggle, you mean?
Huh?
Political power struggle.
Yeah, political power struggle, right? Because company, to begin with, so DevOps really means about creating those self-sufficient teams on many different levels, right? It could be teams that are self-sufficient in creating tooling for other teams. It could be teams creating applications for the end users and so on and so forth. And when I say, hey, let's create this team that will be in full control of this, writing code, testing, building, deploying, blah, 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 then immediately people start thinking, oh, wait, I'm a boss, I'm a manager of the QA department. My power is measured by having 50 people under me. Are you taking people away from me? So it's the biggest challenge is really breaking those barriers, breaking those silos, and empowering, and this is important, it's empowering engineers to do what they think should be done instead of you telling them, hey, you need to do this. That's just silly because managers telling you need to do this, they know less than you. They just get paid more.
Thank you. So your answer is more about people and power perspective, culture perspective. What about technology? So which part of technology is the biggest challenge? Moving a modern version control system or setting up Kubernetes cluster, etc.?
It's let's say day 2 of Kubernetes cluster. Right, setting up Kubernetes cluster is easy. Creating container images is easy at the beginning, and then you and you're very happy because within a month you did a lot. But once you start running it in production, you start realizing the complexities of doing that. Right, things start failing. So it's day 2 operations in Kubernetes. That's always the biggest struggle. Many companies struggle with that, and the major problem is that very often companies start with the idea we're going to move everything. Never do that. Never ever do that. Kind of like take something, move it to Kubernetes, run it for 3 months, be comfortable with it, and also don't go crazy. Like people are tempted. Hey, okay, Kubernetes, excellent. I'm going to install service mesh. Don't kind of like. It's so complicated that you really want to go as simple as possible. So
then how long do you advise for a company from a very ad hoc level to high performance level from DevOps perspective? I mean, with ad hoc, they just write code, they store in locally, so they do not have any build service, nothing, just deploy to, let's say, IaaS server. That's the situation. How long should it take from ad hoc to high performance level for a mid-size company, let's say 100 or 200 people?
It's impossible for me to answer how long it takes, right?
I'm looking for magic
It
numbers
can,
today. Yeah.
yeah, I mean, I don't have a magical number, and it's really hard. It can easily take years or never, right? Because
Mhm.
when you look at the hype, like for example, if you look at DORA report, DevOps something, I don't remember what it stands for. Anyway, it was purchased by Google. DORA report I recommend to everybody. When you see what high performance teams are doing, and you say, hey, I mean, those teams, they're actually making 50 releases to production a day, right? Kind of like high performance is really having cycles that are measured in hours or maybe up to a day, and getting there can take extremely long period of time. Really, really long.
Yeah.
It really depends where you are.
Not in months, right?
Again, depends where you are, right? Kind of like it could be months, because it really depends where you are. And most companies do not know where they are. That's the major problem, right? Because you're closed in a little bubble and you don't really have right things to measure. I really recommend always kind of like get somebody from outside who did it to help you.
So it depends, right?
It depends. I don't have a magical number. I mean, most companies never get there. Let's put it that way. It's so hard that most companies never become high-performance teams.
Yes, you're absolutely right. So when you are talking, you mentioned many popular modern tools. So I will ask again to maybe give a list of popular tools in 2031. What are the most popular and beneficial tools of DevOps? Maybe let's list top 10.
I mean, Kubernetes, cloud. So kind of if you need to move to cloud simply because on-prem is disaster in most cases, unless you're Netflix. So AWS, Azure, even DigitalOcean, Google, doesn't matter, right? You want to adopt something like GitOps, you want Argo CD or Flux. Yeah, eventually, later, not initially, you want Service Mesh. Service Mesh is extremely important, Linkerd or Istio. You need a solid monitoring, that's Prometheus. You said 10, right? You need some form of pipelines. I recommend Argo Workflows. If you want to self-manage, if you want to SaaS, then get GitHub Actions or whatever, right? What else? Let me think. You need some sort of security scanning. I prefer Snyk. Snyk is absolutely awesome. Falco is also great. What else?
What about logging?
Logging, yes. FluentD for shipping logs. And as the destination, either what your provider gives you, like AWS or this or that, or Loki. Loki from Grafana, it's a new project, maybe a year old. Loki is absolutely awesome. So Loki for logging. Do not, Elastic is just horrible. What else? I don't know. Give me two more ideas of the area.
I'm not
you
sure.
want some form of serverless, Knative. Knative for serverless, absolutely amazing.
Did you mention artifact repository or version control?
Version control, I mean, that's Git.
Okay. Then I mean, just one remaining.
Yeah, I don't know.
What about registries? What about container registries?
They're so commoditized that it doesn't really matter. Kind of what if you're in cloud, just whatever your cloud provider gives you. If you're running it yourself, just use Harbor. They're all the same.
Okay, that's great. So thank you. And I think we have a few more minutes left. So I will ask a few more questions. And then the chaos engineering, I personally very interested in chaos engineering and practices. Do you have any advices, tooling practices on that?
On what, sorry, what's changing?
On chaos engineering.
Chaos engineering. Yes.
Yeah.
In the past I preferred Chaos Toolkit. I think that slowly Litmus is taking it over. So Litmus might be a better choice. So either Chaos Toolkit or Litmus, one of the two. And Chaos engineering is absolutely awesome. Yes. That's the 10th category, the one I forgot. Yes.
Cool. Thank you. So, not a technical question, but I'm very curious about it. You have many best-selling books. I follow for a time of period DevOps Toolkit book series, and you have a YouTube channel, very maybe not that popular,
Not that popular.
not
Just
that
started
popular
half a year ago.
on YouTube scale,
Yeah.
but popular for us. And can you please tell the story and motivation behind the books and the channel?
So for books, it was a very good way for me personally to go deep into subjects, much deeper than I would go without books, right? Because when you're playing around yourself, after a while you say, I know everything I care about, right? When you're writing a book, you need to go much deeper into something that you would normally do. So it was for me a way to explore something deeper than I normally would. And then I'm very much into community and sharing. And it's always kind of like, hey, if I'm going to do this, then why not actually allow somebody else to benefit from it? Like, none of those two things like books and YouTube channel, I'm not really earning any significant money. It's not about money. It's really the desire to share. And because I'm taking a lot from other people or from other communities, so I kind of feel that, it's our responsibility to give something back.
Thank you. That's cool. So the lastly, I want to mention you will present your keynote in Test Istanbul conference next October. What will be the subject?
Yeah, it will be a keynote, and the subject, I'm not sure yet. I need to figure it out, but the general gist will be that the Kubernetes needs to disappear. It needs to become invisible. So it will not disappear really, but the next stage in evolution of Kubernetes is to become an implementation detail that nobody cares about, right? The same thing like hypervisors, right? Everybody is using VMs one way or another, but nobody cares about hypervisors, which are extremely important. You don't have VMs without hypervisors, but it became so mature that you jumped on a higher level above it. And I think the same thing is happening with Kubernetes. It is becoming mature enough that you will be using things like, the best example to me is Google Cloud Run. If you use Google Cloud Run, you might even not know that there is Kubernetes. There is, but for you as a user, it's becoming invisible. So kind of, I will probably talk about how we are getting there as industry in general.
That sounds interesting, exciting also. So thanks for your time today.
Thank you.
It was very nice to welcome you here today on DevOpsX Talks. I think it will be also a very good opportunity for Turkish audience to meet you at Test Istanbul conference next October. Do you have any final thoughts to share?
No, nothing special. I mean, I'm fortunate that whichever company I work in is always giving me salary with a lot of freedom. And that means that I can work with other people completely free. So if you have any questions, any doubts, anything, just ping me on Twitter or LinkedIn and I'll do my best to help you out.
Yeah, that's very great because Victor is the master of DevOps tools. Yeah, so you are very lucky to ask questions. Thank you very much, Victor, and hope
Thank
to
you for
see you
having me.
again. Bye bye. Have a nice day.
Cheers.
Cheers.